Hello everyone, welcome back to my channel. In this video, we are going to dive into an essential part of every deep learning workflow, which is loading datasets and applying transforms. So whether you are working with pre-built datasets or creating your own custom dataset, understanding of how to properly pre-process your data and augment it is very crucial in deep learning. So by the end of this tutorial, you will exactly learn how to load, transform and visualize your data in PyTorch. So let's get started. So before diving into the code, first we will try to understand why transforming the dataset is very important. First, they will help standardize your datasets by resizing images or normalizing pixel values. This will ensure that your dataset is in the format that your model can work with effectively. Secondly, data transformation techniques like translation, rotation, flipping, color, jittering can make the model more robust by simulating the real-world variations. And lastly, the transformation of dataset can also speed up your workflow by automating preprocessing. So let's dive into the code. We will be using the cifar 10 dataset for our example, which is a collection of 60,000 images across 10 classes. And PyTorch makes it very simple to use and load this dataset by using the library called torchvision. We will see how we can use this library to load our dataset. So first in our code, we have to use the torchvision library and we have to import our important modules. For this, you can simply type here from torchvision and we are going to import our datasets module, and the next module we need is the transforms module. So the dataset module is responsible for downloading and loading our dataset, and transforms module is responsible for applying the transformation on our dataset like translation, rotation, resizing, normalization, etc. And next library we need is the DataLoader. So to import this, you can simply type here from torch.utils.data import DataLoader. So this DataLoader class is responsible for to load our dataset into batches and fed into our neural network for training. So first we are going to download and load our dataset. So we are going to use the datasets module from the torchvision library. For this, I'm going to create a variable with the name of train dataset, because first I'm going to download our training dataset and we are going to use our datasets module, and from the datasets module we have to use the cifar 10. And you have to create small brackets here, and here we have to pass some arguments. So the first argument is the root. So root is the path for the destination folder where you want to download your data or where you want to load your data from. So I'm going to load or download my data into the data folder. Just type here data, and the next argument is the train. So we are going to download the training data set, so we have to make it true. And the next argument we have is the download. If you don't have the cifar 10 dataset in your project, so you can make this argument true, so it will download the dataset for you. And the last argument we have is the transform. At this stage, I'm not going to apply any transformation on our dataset, so I'm going to just type here none. And next, to see the length or the number of images in our dataset, I'm going to print it. So for this, you can simply type here print f number of images, and you can pass your length and you can pass your train dataset here. Just save your file and run your program to see the results. So go into your terminal, just type here Python 3.12 because I'm using Python 3.12 and my file name is DataLoader, and press enter. So as you can see here, it will automatically start downloading the cifar 10 dataset, and as you can also see here, it has created the data folder. So my dataset will be going to download inside this folder. So after downloading the dataset, it has extracted my dataset, and the total number of images we have is 50,000. So we have 50,000 images in our training dataset. So next we are going to apply some transformation on our dataset. For this, we are going to use the transforms module from the torchvision library. So for this, I'm going to create a variable with the name of transform is equal to, and we are going to use the transforms module. Simply type here transforms dot, and we are going to use the compose from the transforms module, and you have to create a set of small brackets, and inside the small brackets create a set of large brackets. So the compose is usually used to chain multiple transformations into a single command. So here you can pass the list of your transformations, so it will apply all these transformations and store it in a single variable called transform here. So first we are going to apply our first transformation, which is resizing. To apply this, you can simply type here transforms.resize. So create a set of small brackets and create another set of small brackets inside the small brackets, and here you can pass your target size for the resizing. So I'm going to resize all of my input images into the size of 32 cross 32. So you have to simply type it 32 comma 32. So what it will do, it will resize all of our input images into the size of 32 cross 32. So in order to apply the next transformation, you have to put comma here, and the next transformation we are going to apply is we are going to change the format of our normal images into the tensor format. So to apply this transformation, you can simply type here transforms.Tensor and create a set of small brackets. So what it will do, it will change the format of our input images into the tensor format. So what is the difference between in the normal image format and in the tensor format? In normal image, you usually have pixel values ranges from 0 to 255, but in tensors you have pixel value ranges from 0 to 1. And the other difference is in normal image format you have usually number of channels, width and height, and in tensor format you have batch size, number of channels, width and height. So put comma in order to apply the next transformation, and the next transformation we are going to apply is the normalization. We are going to normalize our dataset. For this you can simply type here transforms.Normalize, and you can pass the mean 0.5 comma, and you can pass the standard deviation value here 0.5. So in the last stage all of our pixel values ranges from 0 to 1. After apply this normalization, our values changes from 0 to 1 to -1 to +1. So these steps are really important in order to make your neural network to converge faster during training. So in order to apply the sets of these transformation, you have to pass this variable here. So you can remove now none from here, and now we want to apply these transformations on our training data set, and these transformations will be applied in the same order as we write here. For example, first it will resize all of our images, and then it will convert the format of all our images into the tensor format, and in the end it will normalize all of our images. So now save your file and run it again to see if everything works. As you can see here, the results file already downloaded and verified, and number of images 50,000. As we have got no error, it means that our transformations are successfully applied on our training data set. So after applying the transformation and loading our training data set, we are going to use the DataLoader class, which is used to split the data set into batches and also shuffles them for us, so which is essential for training. So how we can do this? So for this I'm going to create a new variable with the name of, for example, train loader is equal to, and to use the data loader class you have to pass here data loader, and next we have to pass some arguments. So the first thing, you have to pass your training data set into the data loader, and next we have to give the batch size. For this you have to put comma here, and you have to type here batch size, and I'm going to give the 8 for our batch size. So batch size is simply the subset, so it will pick 8 images from our training data set as a batch, as a first batch for our training. And the last argument we have to put is the shuffle. If you want to shuffle your data, you can also put true here. So this is about data loader, and the next we are going to see the size of our images and the size of our labels. For this I'm going to create a loop. For this I have to type here for images and labels. In our train loader we are going to print the size of our image. So image size, for this you can simply type here images dot shape to get the size of the image, and next thing we need is the size of our labels. For this you can simply type here labels size and simply labels dot shape again, and we want to know this only for the first batch, so we have to put break here. So this loop will iterate only for the first batch. So now save your file and run it again to see the results. So I'm going to run my file. As in the results, now you can see that our image size is 8, 3, 32, 32. So 8 is our batch size what we have passed here, and 3 is the number of channels, and 32 is the height and width of our images. Because we have also resized our images in the transform, so that's why you can see here 32 cross 32, and our label size is 8. It means that we have one label for each image. So next we are going to visualize our transformed images. So first of all, in order to visualize, we have to undo the normalization in order to see our real images. So how we can undo the normalization? So we have to use our images here and we have to undo our images. Just type images here, and to undo the normalization you have to reverse the formula of the normalization. So instead of dividing the standard deviation, you have to multiply with the standard deviation. So just multiply with your standard deviation. So the standard deviation we have applied in our transform is 0.5, and instead of minusing the mean you have to plus the mean here. So plus, and our mean is also 0.5. So put 0.5 here, so it will undo the normalization part. So next we are going to create a figure, so we can put all of our images inside this figure, so we will be able to visualize all of our images in our batch. So for this we have to use the matplotlib library. So for this you can simply type here import matplotlib.pyplot and splt. So to create a subplots you can simply type here fig and axis is equal to plt.subplot, and you have to pass some arguments here. First you have to tell the number of rows you want. We just want one row, and our number of columns should be the number of images. So for this you can simply type here length of images. So the images in our first batch is 8, so it will create the grid of 1 cross 8. And the next thing we have to pass the figure size here. So you have to type here figure size is equal to, and the figure size is 12 cross 3. So what it will do, it will create a one figure with the size of 12 cross 3, and inside this figure it will create the grid, and the size of the grid is 1 row and 8 columns, and axis here represents each cell of the grid. So next we are going to iterate over each cell, and we are going to put over each image in each cell. So how we can do this, we have to create a for loop here, for I and image in enumerate images. Now we are going to iterate from all of our images, and we are going to put each image in each cell. So first we have to type here if our I is greater than equal to the length of images, so it will break the loop. And the next thing, we have to put images in our cell. So axis represents each cell, so you have to type here axis. So in the first cell, for example I, in the ith cell we have to show our image, so you have to type here I am show, and in the bracket you have to pass your image here, and you have to permute your image. So you have to type here 1 to 0. So what does permute do? It will actually convert from the format channel height width to height width channel. We have to permute our image because matplotlib only works in this format height width channel, not channel height width. So that's why we have to permute. So what will permute do here? It will go to the first index. So in our format the first index is height, so it will place it at the 0th place here. Next it will go to the second index. Second index is width, so it will put the width here, and in the end we are going to put our 0 index. In our case our 0 index is channel. So when we apply image.permute, so it will change our image format from channel height width to height width channel. For visualization you can also put here print image.shape, and you can also print the permute shape. For this you can simply copy this here image.permute and .shape to see how it converts the shape. And next we are going to put the axis. For this you can simply type here axis I, and we have to put the x and y axis. For this you can simply type here dot axis, and we are going to on it. So you can simply type here on, and in the end to visualize our images you can simply outside from the loop you can simply type here plt dot show. So save your program and run it to visualize the result. So just run your program here. Here you can see all of your images in the figure. So we have created the figure with the size of 12 cross 3. So this is our figure, and we have created the grid with 1 row and 8 columns. So this is our first batch, and you can see all of our images, and our images are transformed and resized to 32 cross 32 as you can see here. So this is how you can visualize your images, and in the results you can also see here for our over each image. The original shape of our image is, for example, the number of channels, height and width. So after permute, it will become height, width and number of channels. Because the matplotlib works only with this format, that's why we have to permute here. So this is it about visualization. And you can also apply some advanced transformations like translation, rotation, flipping, color, jittering, brightness, contrast in order to make your model more robust so it can perform better in real world variations. So in an example, I'm going to show you how you can apply one of the advanced transformations. So I'm going to apply the random rotation. For this, you have to use the same format. You have to type here transforms dot random rotation in order to apply the random rotation, and you have to pass inside the brackets the degree of the rotation. So I'm going to apply the 15 degree of rotation maximum, and you have to put comma here. So it will apply the random rotation in any direction of 15 degree or less. The maximum is the 15 degree. So save your file again and run it in order to visualize the results. And now you can see here in the results that after applying the random rotation, your images are rotated in random directions of around 15 degrees. And this is how you can fed your model with the multiple variations so it can learn more variations and perform better in real world conditions. And that's it. Today we have covered how to download and load datasets, how to apply transformations and visualize the results. These are the crucial steps in building any deep learning pipeline. So if you find this tutorial helpful, please make sure to like, share and subscribe my channel for more PyTorch content, and let me know in the comments what would you like to see next. Thanks for watching this video and I will see you in the next one. Bye bye.